Hey math kids, today we're going to talk about probability density functions. And this first part up here, we can see that a probability density function is defined as a continuous random variable being in between C and D, which is further defined to be like this. So basically we're just finding the area under a curve in between C and D. And then for f of x to be a probability density function, for capital X on the domain from A to B, it must satisfy that f of x is greater than or equal to 0 for all x values between A and B, because probabilities can't be negative. So we see that in this function right here. This does say C and D, but pretend like this said A and B. Everything would have to be above the x-axis. And then the second criteria is the area must be 1 because the total probability must be 1. Okay, so we just have one example today. We're given a probability density function with this defined this way, and we need to check that f of x is a valid probability, it should be a B, probability density function. Okay. So to do that, we let's look at a graph. So the graph, we see that we have that's 3, this would be 0. From the graph, we can see that f of x is greater than or equal to 0 for all x's between 0 and 3, so that works. And then we need to check to see that the area under the curve is 1, and so we need to check that that's equal to 1. If we take the antiderivative, it's going to be x to the 3. We already have 1 over 9, and we need to do 1 over 3. So if we multiply those together, we're going to get x cubed over 27. And if we evaluate that from 3 to 0, we're going to get 3 cubed over 27 minus 0 cubed over 27. 3 cubed is going to be 27 minus 0, and so we get 1 minus 0, which is just 1, and so we know that this is a valid probability density function. And then the last thing is we need to actually do the problem, and so if we're going to go from 1 to 2, we just need to find the area under the curve between 1 and 2. So we're going to do most of the same math right here. We can even jump to right here. X cubed over 27. This time we'll evaluate from 1 to 2. So 2 cubed over 27 minus 1 cubed over 27. So we're going to get 8 minus 1 over 27. So we get 7 over 27. If you have additional questions, please come to Math Lab. Until then, calculator.